Hello, fourth graders. I am creating our first math lesson video, and I'm going to try to teach you math from home. I brought our whiteboard from school, and I hope that this is going to work really well for you to follow along with lesson 80 as we learn about mass and weight today. So the first thing that we will do is have you go ahead and do your mental math part of our lesson, which is on page 531 in your math books. And so go ahead and pause this video and go ahead and do problems from the mental math directions all the way down to letter H. Okay, so now as soon as you are finished with A through H, and I would like you to do this on the back of that special paper that I made for our class, where there are 6 different problems on one page. So I want you to turn that packet over to do your mental math each day. And let me give you the answers to that. So for letter A, number sense, 45 minus 39 is 6. For B, 56 minus 27 is 29. C, 63 minus 48 is 15. And D, 82 minus 35, you should have had 47. And for letter E, it was a powers and roots problem. And it said compare the square root of 16 minus the square root of 9, then there's the circle for comparison, to 1 squared, or 1 to the second power. And you should have had equals. Those two are equals. The square root of 16 is 4, minus the square root of 3. 4 minus 3 is 1, compared to 1 squared, or 1 to the second power, which is 1 times 1, is 1. So it's 1 compared to 1, and of course those two are equal. Letter F, the high temperature was 84 degrees Fahrenheit, the low was 68 degrees Fahrenheit. The difference between the high and the low temperatures was how many degrees? This, of course, is a comparison problem. You think 84 minus 68, and you should have gotten 16 degrees as the answer on that. Letter G, each candle costs $3.05. If Miranda has $12, does she have enough to buy 4 candles? $3 plus some change times 4 is more than $12, so she does not have enough to buy 4 candles. Your answer should have been no. In letter H, you have 1/4 of 24, which of course is 6, times 9, which is 54, minus 15. Let's see, 54 minus 10 would be 44. Minus 5 more would be 39. 39 plus 51. Let's see, that ought to give you 90. Did you get 90? I hope you got 90 on that. Then we have the choose an appropriate problem-solving strategy to solve this problem. Of course, we do not have our problem-solving strategies here, but I think we've used them enough to really know what options we have. It says, Talia's soccer team, the Falcons, won their match against the Eagles. There were 11 goals scored altogether by both teams. The Falcons scored 3 more goals than the Eagles. How many goals did each team score? And we won't take the time to figure all of this out together. I will tell you that the Falcons, you should have had 7, and the Eagles 4. This will bring us to one of the most important parts of our lesson, which is the new concept. Now, the best thing you could do here is to pause the video and to go ahead and read over page 532, 533, and all the way through example 5 on page 534. I will try to give you some of the highlights of that lesson though here on our whiteboard. So today, I hope you can see this. This says Math Lesson 80, and it also says that our topic today is mass and weight. Okay, let's see if we could get this situated a little bit better. Mass and weight. So mass and weight are two things that are related, but there is a difference between the two. Okay, so the mass of an object, as we see on page 532, is how much matter an object has within itself. So basically how much matter, how much stuff is in the object, how many protons, neutrons, electrons are in an object. Of course, you learned a little bit about those in your science chapter. So mass again is how much stuff, how much matter an object has within itself. Weight is slightly different. Weight shows how heavy an object is. It is the measure of the force of gravity on that object. So how much pull of gravity is there on that object? So as it says at the top of page 532, it says, though an object's weight depends on the force of gravity, its mass does not. All right, so for example, well, we'll read first. It says, for example, the force of gravity on the moon is less than it is on Earth. So the weight of an object on the moon is less, even though the mass remains the same. So if I decided to become an astronaut, maybe one of you will decide to do that one day. I think I'll stick with teaching myself. But let's say one of us wanted to become an astronaut. Now, for example, let's say the child, let's say it's one of you, somebody who's really light. Let's say you weigh 60 pounds, which I know is really light for a fourth grader, right? Maybe one of your little siblings. But let's say that right now, the lightest person in our classroom maybe is 60 pounds, and that person had an opportunity to go on a rocket ship up to space and landed on the moon. Well, the force of gravity, the pull of gravity on the moon from the Earth is about 1/6 of the force of gravity, of the pull of gravity that we have on the Earth. So basically whatever your weight is, if you were 60 pounds, divide that by 6 on the moon and you would weigh only 10 pounds. So would your mass change? No. You would still be the same person. You would still have the same amount of stuff that makes up your body and same amount of matter within you. So when someone says, I really want to lose weight, what they're really saying is, I want to lose some mass. I want to lose some mass, some of the stuff that makes up me, so that I can weigh less, so that the pull of gravity on my body is less. Okay, so we measure weight, the pull of gravity on something. We measure weight in the United States, in the U.S. I've told you how there's the U.S. customary system, that we use in the US obviously, and then there is the metric system that is used through much of the rest of the world. And in the US system, we use ounces, pounds, and tons. Now take a look at that little chart right about in the middle of page 532 that tells us that 16 ounces is equal to 1 pound. And 2,000 pounds, LB is short for pounds, is equal to 1 ton. Okay, so 16 ounces is 1 pound. So if you were to have a 16 ounce apple, let's say, and you put it on the scale, then it would probably weigh about maybe half a pound to a pound. So that's about 16 ounces. Now, a whole bunch of pounds, if you were to put together 2,000 pounds of something, now that would be equivalent to 1 ton. So as we go down, you can see a box of cereal. In our book says that it might weigh about 24 ounces, so more than a pound, maybe closer to 2 pounds. A child, let's say, may weigh about 98 pounds, one of the heavier kids in our class. A little stronger, a little bigger kids might weigh about 98 pounds. And a small car would weigh about 1 ton. Okay, now if you take your own math book, pick it up for a second. Okay, mine's a little bit heavier than yours as my teacher's book, but your book weighs about 2 pounds. And so the first question is, well, 2 pounds is how many ounces? Okay, and we see that 16 ounces, as I'm going to write here, I hope you can see that, equals 1 pound, 1 lb. Then how many pounds? The question is, 2 pounds is how many ounces? So if there is 16 ounces in 1 pound, then 2 pounds, we would just double it, and we would get 6 times 2, of course, is 12. 2 times 1 is 2, plus 1 is 3. So 32 ounces, it equals 2 pounds. 32 ounces equals 2 pounds. Okay. Let's see, as far as ounces go, to kind of give you an idea of an ounce is about the size of a small paper clip. So can you see that? I chose some colorful paper clips. This is a smaller one. We usually use the larger ones in the classroom to clip our papers together. The paper picker-upper person uses those all the time. This is a smaller paper clip, and this little paper clip weighs about 1 gram. 1 gram is a metric unit. So instead of the US customary unit, in Europe, for example, we would measure something like this in a gram, as a gram. So I've pulled up a couple of things to show you. One, in the first tray here, I have the 1 paper clip. Okay, and that, remember, weighs what? 1 gram. Okay, now if I was to have, instead of 1 of those, if I had 28 small paper clips, you can see I have some colorful ones, purple and red and blue and different ones. So 28 of these grams, 28 grams, would be equal to 1 ounce. Okay, so these are just some little ideas of things you can think about and try to remember as we go along. So remember, 16 pounds is 16 ounces equals 1 pound, excuse me. We figured out 2 pounds was 32 ounces, and I'm going to go ahead and do my best to erase this now. Okay. All right. The next, we have example 2 in our book. Let's look at example 2 on page 533, which tells us the rhinoceros, one of the coolest animals I saw in Africa. The rhinoceros weighed 3 tons. Okay, 3 tons is how many pounds? Okay, so we have to think about our little scale that we have, the U.S. customary scale that we saw on page 532 in the middle of the page, where we found out that 2,000 pounds equals 1 ton. So if 2,000 pounds equals 1 ton, then, and we're talking about 3 tons, then I think it would make sense to you that we would say 3 tons times 2,000 pounds. All right, 3 times 0, 0, 0, 0, and the 6. So 2,000 pounds times 3 tons is going to equal 6,000 pounds. Okay, so, and of course, a good way to write this is just writing out the word pounds. So 6,000 pounds. So the next thing our book mentions is what I have already brought up, which is the metric unit of mass. Metric units of mass. They are not just the grams, which is what that little paper clip, what the mass was of that little paper clip, but there's also grams. So as our book says, recall that the prefix kilo means 1,000. So a kilogram is 1,000 grams. So you saw my 28 grams. That was the equivalent of 1 ounce. So 28 grams, 28 little paper clips in the metric system would be equal to 1 ounce in the US system. Okay, now I happen to have here this little method cleaner, which is one of the ones I really like to use in my home. And this, as you can see here, it is measured in US ounces. It says it's 28 fluid ounces. And that's what we see most of the time in the United States. It also says here it's 828 milliliters. And that is the metric unit that's the same as 28 fluid ounces. But I think of liquids, how much is in here, usually in ounces, because I live in the US, right? So let's see. So kilo means 1,000, as we see at the top of page 533. And so if you have 1 gram, like this paper clip, and you add the word kilo to the front of it, now you have 1,000 grams. So there we have our next notation here that I will also write on the board for us to think about, which is that 1,000 grams, which is like one little paper clip, 1,000 grams equals 1 kilogram. kg. We do not need to put the, we do not need a period or to abbreviate kilogram. It's just G or kg. So think of it as 1,000 paper clips will equal 1 times 1,000, because the K stands for 1,000 grams. Okay, so do you see that? I hope you can see that. Let me turn this a little bit. So 1,000 grams, like 1,000 paper clips, is equal to 1 kilogram. Gram. So add the K in front of it, it means 1,000. Okay, let's see. It also mentions here in our book that $1 bill has the mass of 1 gram. And your book has a mass of about 1 kilogram. So 2 pounds, we said earlier, is the weight. And how much mass does your math book have? About 1 kilogram. So then it says, since this book has fewer than 1,000 pages, pause for a second and check. How many pages does your book have? Okay. It says each page is more than 1 gram. Hold on one second while I go grab my book. Thank you for your patience. So I have a book just like yours at home. And let's see, there's a glossary at the back. But what I'm seeing is we have, well, I have the volume 1 in front of me. You have volume 2. But in volume 1, we have roughly just over 400 pages. So with 400 pages, and each page is about the equivalent of a gram. And if we were to say, it says, so let me read it. A dollar bill has a mass of about 1 gram. This book has a mass of about 1 kilogram. Okay, so if this book, and that's a fact they're telling us, has a mass of about 1 kilogram, and this book has fewer than 1,000 pages, then each page has to be way more than a gram, right? So let's move on to example 3, which tells us to choose the more reasonable measure for A through C. So now let's think about these items that are listed in example 3 on page 533, a pair of shoes. Okay, so think, does it weigh, would you measure it, how much mass is there in this, in a pair of shoes? Is it closer to a gram, like the paper clip, about that much mass, that much stuff in it? Or is it closer to maybe 1,000 of those? I guess it depends whose shoe you're talking about, right? Mr. Nagy's shoe would probably even be a lot more than even 1,000 paper clips, right? So let's say that the pair of shoes is closer to 1 kilogram than it would be 1 gram, right? How about a cat? Would a cat have as much matter as 4 grams? 4 little paper clips, or maybe closer to 4 kilograms? Well, I don't know about how big your cats and dogs are. I saw a few on our program, but let me call Izzy over and let's take a look at her. Izzy, come. She isn't the most obedient dog. Come here, Izzy. All right, so let me introduce you to Izzy. Izzy, don't worry, you're fine. Here we go. We are teaching math right now. Now, Izzy is a very little dog. She may not look that little right now, but she is actually pretty tiny. Look at her little dress that she has on today. So my question to you, I would say she is 5 pounds. This dog, about 5 pounds. But the question would be, that would be kind of like a mid-sized cat, I would say, maybe a bigger cat. So the question would be about a cat, or maybe Izzy. Would she have the amount of matter? How much stuff is there here? Is she closer to 4 grams or maybe 4 kilograms? All right, and I'm sure that you could see that she does not weigh anything close. Not weight, I'm sorry, how much stuff there is that makes up Izzy, how much matter, how much mass is not close to a little paper clip. Thanks for your help, Izzy. Bye. All right, and she's off to play with her toys. And did you hear her sneeze? She sneezes when she's mad at me on purpose. It's kind of a scoff. Like, oh. So she just sneezed. I guess she didn't appreciate being part of our video. Oh, well. So then the next thing is a quarter. A quarter, would it be closer in weight? Let me pick up 5 grams worth of paper clips, 5 paper clips. Quarter, would that be closer in the amount of mass of 5 grams, excuse me, or 5 kilograms? And the quarter is closer to 5 grams. Okay, so next is example 4. How many grams are equal to 5 kilograms? Okay, so that brings us back to our board here. Our board, let me readjust it again. Hopefully you can see that okay. I think you can. All right, so the question is, again, how many grams are equal to 5 kilograms? We can find the answer by setting up a table, okay? Now, we could also just think of it like up here. If 1,000 grams is 1 kilogram, then 5 kilograms, wouldn't that be the same as 5,000 grams, right? We would just multiply by 5. But we can also set it up on a table. It's another strategy that we use in our class for problem solving, right? And we can see, look at kilograms and grams. When we show 1 kilogram, it's the same as 1,000 grams. So 2 kilograms is the same as 2,000 grams. 3 kilograms is 3,000 grams. 4 relates to 4,000, and 5 kilograms is 5,000 grams. All right, then it says we can write a formula for converting kilograms to grams. Okay, we use G for grams and K for kilograms, and we can write this formula. We can say G. So instead of now writing the 1,000 grams, we can get rid of this word 1,000, which is still the paperclip side, right? 1,000, and we could just write G, or grams, equals, very simply, we can say grams equals 1,000 kilograms. So grams, or gram, I should say, which is the same as 1 gram. 1 gram, so gram equals 1,000 kilograms. So we could leave it just like that. Or we can switch to 2, and we can simply say 1,000 kilograms equals a gram. Doesn't matter which way you read it first, means the same thing. Okay, and then it showed us how could we rewrite the formula grams equals 1,000 kilograms using X and Y. So instead of using G and K, actually I wanted to get rid of the, let's see, what was I thinking? What I was thinking is I don't even need this G. I could just leave the K, which means kilograms. So gram equals 1,000 kilograms. That's how our book writes it for us. But we can also leave the G, and it doesn't hurt anything. Okay. So the question is, can we use X and Y, so like two unknown variables, to change the K and the G into an X and a Y? And we could say, how about instead of the way it's written here, what if we were to say 1,000 X's, or 1,000 kilograms, equals 1 gram. So 1,000 of X is Y. So that's just one way that we may need to use to switch out the kilograms and grams. We might know the X or the Y and not be told what the K or the G, and then have to figure it out. So sometimes they will put in an X or a Y for one of those instead. That brings us to example 5. Let's see. It says, Mr. and Mrs. Gordon purchased 2 salads at the salad bar. The salads weighed, and if we were in class, of course, I would have you read this to me together in class. The salads weighed 1.43 pounds, but as fourth graders, we don't use the word point. We read that as 1 and 43, stops at the hundredths place, so 1 and 43 hundredths pounds, and 1 and 37 hundredths pounds. So 2 salads, person purchases 2 salads. 1 and 43 hundredths pounds, LB, stands for pounds, and the other is 1 and 37, stops in the hundredths place, pounds. And it says, to the nearest tenth of a pound, how much did the salads weigh? Okay, so now we know that this here on both of them is the 10th place. So all we're doing in this problem is that we are going to round each number to the nearest tenth. Okay, and then we're going to add them up to figure out what the total weight of the salads are. Okay, so 1 and 43 hundredths pounds, and we're looking for the 10th place. We want to drop off the other. So this is going to now become 1. Remember, you look at the 10th place and you say, is it higher or lower than half, higher or lower than 5? And since it's less than 5, we're going to round it to 1 and 4 tenths pounds. Okay, is that showing up on the screen? I think it is. 1 and 4 tenths pounds. And here we have 1 and 37. We want to drop off that 7 to round it to the nearest 10th place. And remember our little rule, 5 and above, give this a shove. 5 or below, let it go. Well, the 3 needs to be shoved up to become 1 and 4 tenths pounds as well. And then if you were to add those two together, 1 and 4 tenths of a pound and another 1 and 4 tenths of a pound, which is, by the way, like 1 pound and a little bit less than half of another pound. So almost 1.5 pounds, right? And we add these two together, 1 and 4 tenths plus 1 and 4 tenths, we are going to get 2 and 8 tenths of a pound. Let's see. Next, it says the restaurant charges $2 a pound for a salad. So this is a little more than 2 pounds, right? So, and they charge $2 a pound. So one of these pounds will be $2, another $2, and of course, if it's close to the next pound, like this is close to 3 pounds now, they're going to round up to the next pound, right? So that will mean that for almost 3 pounds, they're going to charge $2 a pound, okay? But we don't really want to do the 2 8/10. Why don't we also round this one 2 8/10 to 3 pounds, and 3 times 2 then is 6 pounds, okay? So they are going to, did I do that right? Let me think. The cashier will round up to the nearest pound. How much did the Gordons pay for their salads? I'm sorry, what I meant to say is $2. This $2, which is going to give us $6 down here. So not 6 pounds, but $6, excuse me. Okay, so that is basically our lesson on mass and weight. We do have the lesson practice problems to do next. So let's get started on those. I'm going to erase the board while you, on the back of that special paper where we did our mental math, about halfway down, very neatly, write lesson practice on the left, and then start with letter A. Leave yourself plenty of room, write small enough, and I will be grading every homework assignment for accuracy since you are at home. So you do want to not have any of these of your homework problems that are incorrect, okay? And if you get anything incorrect here, then we'll have you change it and fix it, okay? So let's start our lesson practice problem. So you go ahead and start without me, and I will catch up to you in just a moment, students. Okay. All right. The first question, letter A, says Dave's pickup truck can haul a half ton of cargo. How many pounds is a half of ton? Well, if 1 ton, remember, is how much? 1 ton is 2,000 pounds. We saw in the middle of page 532. Then a half a ton is going to be 1,000 pounds, right? So for letter A, the answer was 1,000 pounds. Letter B, it says the newborn baby weighed 7 pounds and 12 ounces. The baby's weight was how much less than 8 pounds? Now here we have to think about that. How many ounces make a pound? Do you remember? You can check back on the page, 2 pages before, which told us that 16 ounces is 1 pound. Okay, so maybe tonight you could find out from your parents, if you don't know for sure, how many pounds and ounces did you weigh? Were you a perfect 10 like my daughter Lily? She was born exactly 10 pounds and no extra ounces. Or were you like Destiny? She was 8 pounds, 9 ounces. Big babies, both of them. And so 8 pounds, 9 ounces. So Destiny was really close to that 9-pound marker. So for a baby, that was 7 pounds, 12 ounces. And to make that 8th pound, we need 16 ounces for B. 16 ounces minus 12 ounces to give us that last pound that we need, obviously, is 4 ounces, right? 4 OZ, we say. So about 4 ounces. 4 ounces more would have made that baby 8 pounds. All right, now it says to estimate, excuse me, for letter C. Okay, a tennis ball. Would you say it is closer to 57 grams, which would be not 28 paper clips, the mass of 28 paper clips, but a tennis ball would be closer to probably 57 grams, wouldn't you say, for a yellow tennis ball? Much closer to that than 57 kilograms, which is much, much bigger. That would be like 57 times 1,000 more grams, so much, much bigger. A dog, again, now would, oh, let me write that down, sorry, see? So 57 grams is what we want you to have there for letter C. Now what about letter D? A dog. Would a dog's mass be closer to 1, 2, 3, 4, 5, 6 grams? Or 1,000 times as much, 6 kilograms? So we are going to say a dog, like my dog Izzy, would be closer to 6 kilograms. Okay. Letter E. How about a bowling ball? Would it be closer to 7 grams? Remember gram? About the mass of a paper clip, how much stuff there is, or 7 kilograms. Kilograms is bigger. Bowling balls are pretty heavy. Do you bowl? I really enjoy bowling. I'm kind of good at it. I don't know about you, but I don't really know any specific techniques, but somehow I hit those pins when I go pretty well. So letter F. Letter F, I hope you can still see that. Letter F says 7 kilograms is how many grams? All right, well, we said earlier, let's look back at, so if we have 7 kilograms, okay, that would be the same as saying the 7 times, I'm sorry, whoops, wrote the wrong thing. Let me get rid of that. 7 times 1,000, because the kilo means 1,000, right? So this is 7 times 1,000 grams, which is going to be 7,000 kilograms. Can you see that? I think you can. Okay, I'm kind of writing a little bit sideways, so it's not as neat as usual. Sorry about that. All right, which brings us then back to the last part, letter G. And I'm running out of room, so I'm going to erase all of this. Okay, so letter G. And it asks us, which depends on the force of gravity? The mass of an object or the weight of an object? Okay, and remember we said basically the answer is weight. Weight. Because remember what we originally said, weight is the measure of the force of gravity on an object. Okay, weight shows how heavy an object is, how heavy. And mass is how much stuff is there. Again, how many protons, neutrons, electrons, and so on. All the stuff that makes up something. So if I go up to if I was personally, Mrs. Nagy, if I was to go up as an astronaut to the moon, the amount of mass I have would be exactly the same, but I would weigh less because with let's see, let me draw something for you here. Okay, here's the Earth. Okay, and then let's say here's the moon that is going to be, right, rotating around the earth, right? And the earth is, so if gravity is this force that's pulling us to the middle of the earth, me standing over here, there I am. Here, let me give myself some reddish hair. So here I am standing on the earth. The pull of that gravity is going to be stronger for me while standing on the earth than it will when I'm standing on the moon. Whoops, so now I drew my whole body red. There we go, let's make that. Same clothes, same person, right? And then just a little further out in space, there's my crazy hair. And I'm going to weigh 1/6. So divide my weight by 6, and I'm going to weigh a lot less. So where I am will make a difference in my how much I weigh, because weight is that measurement of how much gravity is pulling on you, while mass is the amount of stuff that I'm made of. My bones, my skin, my organs, a little extra fat, all those things make up all of me and my mass. And so whether I'm on the earth or whether I'm on the moon, my mass is exactly the same, but my weight will change. If I'm up on the moon, it will be 1/6 of what it is here on earth. All right, so that is our entire mental math, which needs to be on the back of your paper. Our entire our new concept. We went through all the examples, and I hope you followed along with that, and then our lesson practice problems. And for sure, our mental math and our lesson practice problems needs to be on the back of your paper. But it's really good to take notes too. So maybe you found some space there to take notes as we went along. Or maybe you just listened, which is okay. So let's move on to our written practice problems now. Let me clear this off. And you can get started on the first star problem. Of course, if Jonathan was here, he would tell us which one that is, but it looks like I'm going to have to look for myself, right? Which is not hard. Number 2, and we see that above number 2, that's our first star problem. So what I would like to do is go through the star problems with you, and then have you do, like you usually do for homework, the non-star problems with help at home. So hopefully this will work well for you, pretty much what you're used to doing. Number 2, our first star problem says a container and its contents weigh 125 pounds. The contents of the container, so what's in the container, the contents of the container weigh 118 pounds. What is the weight of the container? Okay, so now we have the container, right, plus all the stuff that's in the container, whatever that is. And we said that this weighs 125 pounds. The container itself is pretty heavy, and that weighs 118 pounds. 118 lb for pounds. Okay. Now, can you see that this is going to be a comparison problem, right? 125 pounds. If you take out the stuff on the inside, its contents, the container itself is 118 pounds. You're going to subtract the two, and can you do 125 minus 118 in your head? I think you can. and you will see that the difference is 7 pounds. Okay, and of course you can do the 125 minus 118 if you need to. It's no problem. We cross out the 2, put a 1, carry 10 over, so we have 15 minus 8. What is 15 minus 8? It's 7. 1 minus 1 is 0. 1 minus 1 is 0. And there's your 7 pounds. Okay, so that is number 2. All right, so I'm going to leave that up there for a moment. And I really hope you can see that well. And we're going to go on to problem number 3. All right, now whatever I draw on my board, just like at school, I expect that it will be on your homework paper. And for the next 2 weeks, I sent 5 packets home. This first week of school, we have two lessons. We have today's lesson and tomorrow's lesson, which is Investigation 8. And I went ahead and copied the regular Investigation 8 papers for you, so you'll just follow along easily on that. And also, by the way, for tomorrow, it would be helpful if you brought your fraction circles. So look for your fraction circles. If you left them at school, then they should be in the brown paper bag that we are sending home on Tuesday for you. And if you put them exactly where I wanted them, then you would find them in the front of your math book, in your inside of your cover. I don't have a cover, but all those extra reference materials, remember I asked you to keep them inside of your math book cover. Back to number 3. It says, Angelita is shopping for art supplies and she plans to purchase a sketch pad for $4.29, a charcoal pencil for $1.59, and an eraser for 69 cents. If the amount of sales tax is 43 cents and Angelita pays for her purchase with a $10 bill, how much change should she receive? All right, so it sounds like we need to know how much the total is of everything. And then we're going to need to subtract that from $10 to see how much change she will get back, right? So let's go ahead and very carefully write these numbers down. The first number is for the sketch pad cost. So we should write $4.29. Okay. The second number is for the charcoal pencil, which is $1.59. Okay. And then the third part of this is an eraser, which is just 69 cents. Right? So that means it's $0.69. And this is where we sometimes get tripped up as 4th graders when we don't, we forget that there's a 0 here. So we're going to add all these numbers together. Let's see. What is 9 times 3? All right, we're going to put down, carry a 2. We're going to put down that 7. Then let's see. We have 2 plus 2 is 4, plus, I'm going to jump to the 6, makes 10, plus 5 is 15. Okay, and then we have $4 plus another $1 and another $1, so this is $6.57. Okay, and is that all of it though? Are we done? We got to $6.57. And then it tells us that the sales tax is 43 cents. Don't forget the sales tax. So now I have $6.57 plus our sales tax, which is 43 cents, $0.43. Okay, 7 plus 3 is 10. Put down the 0, carry the 1. 5 plus 1 is 6, plus 4 is 10. Put down the 0, carry the 1. Don't forget your decimal place, just bring it straight down. Keep all of your numbers in line. And the 6 plus 1 gives us $7. Okay, so now we've added all the amounts together. We've added the tax, the 43 cents, and that gave us $7. Are we done? Hopefully you're saying, no, we're not done. It says if she pays for her purchase with a $10 bill, how much change will she get back? So she gives them $10. The amount of the whole purchase was $7, including the tax. So she will get back $3 in change. Would you write that? Wow, that was a lot of writing to just figure out number 3, right? Some of you, perhaps, you could do this in your head. That would be awesome if you can. I don't expect you to. That would be a bit difficult to do in your head. Quite difficult for most of us in 4th grade. But whether you can do it in your head or not, and I wouldn't think you can just yet, and good for you if you can, I want to see all of your work. I do not want you to just write number 3. The answer is $3 and change, okay? Because I would consider that incorrect. I would be marking that off and you would be redoing it later at home. So let's just do it right the first time, okay, and show all of our work. All right. Now, let's see. The next star problem, Jonathan, is number 5. That's right. Go ahead and start number 5 while I clear this board. Now, if I'm going a little fast for you, what's really neat is you can just press pause on your phone or laptop as you watch this YouTube video, and you can take your time to write all of that down, okay? But fortunately, I need the room on my board, so I'm going to go ahead and erase it. All right. All right, let's see, what's next? Number 5. Okay, let's see, I lost my pen. Where is it? Here we go. Number 5 says, from 3 p.m. to 3:45 p.m., the minute hand of a clock turns how many degrees? Okay, so this is where we need to think about degrees. And if you look back to lesson 78, you could turn back to lesson 78. As you can see in the little parentheses under the number star 5, it says that this is a lesson 78 problem, which you did at home without me right before spring break. So I hope that you have a good sense of degrees. Okay, so but let me see how to quickly review that. So let's look at a clock. All right, and this is right the 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock on a regular clock face. Okay, if you are facing this way toward 12 o'clock and you're maybe I should put it right on there. Let's say that we're pointing to 12 o'clock and then next we're pointing to 3 o'clock. We have moved, do you see that angle? 90 degrees. Okay. If instead, if we keep going, if this hand keeps moving and ends up here, that is another 90-degree angle, isn't it? And 90 plus 90, it's like 9 plus 9, add a 0, is 180. So now altogether, up until here, we move 90 up until the 3 o'clock. But if we go all the way down to here, we have gone 180 degrees. So this 90 degrees is a quarter turn, another 90 degrees, another quarter turn, gives you 180. But if you were to keep going and turn this direction now, you would be at 9 or 90 times now 3 different 90-degree turns. So what would that make? It's the same as 9 times 3, which is 27, add a 0. So you'd have 90, 180, 270. And what's 270 plus 90? If you were to go another quarter turn, that is 360 degrees. Okay, so let me show you with a little example here, okay? 1 second. This here is Izzy's little Easter lamb, our little dog Izzy's lamb. And I mentioned the other day, even though this is brand new and I got her this for Easter, she has already taken out the eyeballs. See that hole, okay? So, and she's managed to take out eyeball number 2. So anyway, my little rascally dog. So what I want to show you is, let's say that here is little lamb. I'm calling little lamb. And if little lamb turns a quarter turn, that little lamb has just turned 90 degrees. Another quarter turn, you're going to see its back. And now little lamb has turned 180 degrees. So completely backwards. It's like in Bible when we say you repent, you were going one direction, you're going to go completely the other direction. That's a 180 degree turn. Let's go back to the beginning. So here's little lamb facing you, 90 degrees, facing me, another 90 degrees, which is 180 now. Another 90 degree turn, and that would be now at 270 degrees, and another 90 degree turn facing back to you is a 360 degree turn. So 360 degrees means facing you all the way back to facing you again, okay? A 180 degree turn is facing you and now going the exact opposite direction, okay? Like when we repent and go do the opposite of what we were doing, okay? So anyway, back to this problem. It says from 3 o'clock, thank you, little lamb, back to Izzy's bed there, okay? So the question was from 3 o'clock to 3:45. Isn't this where 3:45 is? 3:45, right? Let me fix this clock up a little bit. Erase all the extra stuff. Okay, so here's my 9 o'clock. Let me get rid of the 180. Best that I can. And so we have 3 o'clock, and then 45 minutes would be, let's see, I could actually draw all the numbers for you. Okay. And so we have 3 o'clock and something, 3:45. So actually the clock would be a little bit lower. And then let's draw that's the hour hand. We're trying to draw 3:45. So let's count now for the minute hand. 5, 10, 15, 20, 25, 30, 35, 40, 45. And hopefully you already know that the 9 is where the 45 minutes is. So it would be 3, the minute hand is longer, 3:45 p.m. And so the question was, how many degrees? And it was 90 plus 90, another quarter turn, and that is 270 degrees. Okay, Can you draw all that, please? Can you have that on that problem number 5? All right, I'm going to move on, but if you need to stop here, just pause the video for a moment, write this down. 345 is 270 degrees. Draw a quick clock, get that information down, and then start the video again right where you are. And I'm going to go ahead and erase and move on. If you are ready ahead of me, of course, you get to go on to the next star problem, which is number 9 in this case. Now, number 9 says, what fraction of the set triangles is shaded? Okay, so you have all these triangles. Remember that there's the numerator at the top and the denominator at the bottom. And we count how many circles there are all together. And if you count carefully, there are 10 circles. And how many of them are shaded, which means different than the white paper. They're shaded blue, 3 of them. 3/10 of the triangles are shaded, 3/10, right? Let's move on to number 11, problem number 11, which says write each decimal number as a fraction. All right, so I see in letter A something that looks like 0.1, right? 0.1. And if you don't read it like a younger child and say 0.1, if you read it like a 4th grader, then you will know this is 0, the dot means and, 0 and 1/10. So if you just read it, you could ignore the 0 and just say this is 1/10, right? And there's your fraction. Here's your decimal. We turned it into a fraction. Just by saying it out loud, I think you'll figure it out. So letter B, we have 0 and 1/100ths with the little tongue sticking out, 100ths. And so we just simply write, we can ignore the 0 and, because that's just 0. It doesn't stand for anything. So 0 and 1/100ths. Okay. And then finally, letter C. I hope you can see that. Letter C, there's 1 and 11. And this we would write as 1 and 11 over 100. And we say 1 and 11/100ths. Okay. All right. So pause the video if you need to copy that down. And we will move on to number 11, star problem number 11. Nope, not number 11, I'm sorry. Number 20 looks like is our next star problem after number 11. Yes, so number 20, which says 10 times 23 cents. Number 20 says 10 times 23 cents. What do? We take 23 cents, add a 0. Okay, so we have 23 plus that 0. And we can see 23 cents times 10 is going to be more than cents. Now we're going to add, now times 10 is going to give us $2.30. And you might wonder, well, how did you know that exactly? So let's think about what this actually means. If I rewrite the cents to look more like the way we write dollars, it makes a little bit more sense. So we might say 0 and 23 cents, okay, times that 10, right? And now we can see that there are two numbers that are behind decimal places. So we also know that we have 23 because it's basically 23 times 10 would be like writing, it's a multiple of 10. So remember how we learned that you could just say times 1 and then add the 0 at the end? So it's 23 times 1, add the 0 at the end, and figure out how many places are behind decimals. 1, 2. So in your answer has to have 1, 2. Dollar sign is $2.30. Okay, and we didn't have to multiply anything by that 0 because 1 times 0 is 0. So I never wrote that down. Yes, okay, so that's number 20. Next we have number 21. Which says 62 times 30. 62 times 30. We're going to, because it's a multiple of 10 again, I'm going to leave that 0 off to the side. 3 times 2 is 6. 3 times 6 is 18. And then add that 0 back. And we have 1,860 as our answer to number 21. Number 22. Let's see, we have, I'll do it down here, 70 times $25. Now this is, again, where it makes sense to go ahead and, well, actually, we could just say $25 times 7 with that 0 off to the side. $25 times 70, multiple of 10. The author of your book would want you to do it this way. And now think, this is $25. This is not 25 cents. So really, the decimal place and zeros would be over here, right? But we're not going to complicate it by adding all those zeros. We just know that it's $25 times 70. Whatever can come, decimals after that doesn't matter. So let's just go with the simple way to do it, which is 7 times 5 is 35. Put down the 5, carry over the 3. Ooh, it's a little bit glary, isn't it? Now 7 times 2 is 14, plus 3 is 17. Let's see. Okay, so we have 175 from the 25 times 7. Don't forget to bring down that 0, right? And don't forget that this is about money. So $25 times 70 is going to be, gosh, almost $2,000. Excuse me for the euphemism, gosh. I take that back. So 1,750. And then if you were to think about the cents over here, then wouldn't the cents also be 2 decimal points back here? It's $1,750. But we do not need the extra stuff there. We don't need the cents. So that's number 22. All right, so on to number 23, a division problem. Okay, we have number 23 and number 27 and number 30 left. So let's go ahead and complete this lesson that way. And then you can start your non-start problems. Maybe take a little break. I know I'm going to need a break after over an hour of doing math with you. Okay, so where was I? number 23, I think. 23. See why I have Jonathan keep us going? $6.27. It says divided by 3. Okay, so we have a dollar sign up there. It's just going to remind us to put the dollar sign up at the top, and that's it. So we have $6.27 divided by 3. So now we think to ourselves, how many times does 3 go into 6? Boy, I haven't done division with you in like a month. It's been a while, over a month. Hopefully it's still pretty fresh in your brains. You've done it just 2 weeks ago. But you think, what number up at the top times 3 gives you 6? You know that's 2. So since we're going to put that 2, I'm going to right away think to put that decimal point up above because it has to match up above. Then I'm going to say, okay, 2 times 3 is going to give me a 6, right? So I'm just going to put that 6 underneath this other 6, and then I'm going to subtract it. 6 minus 6 is 0. Okay, so we're not finished, obviously. We have another number, this 2, that we're going to very carefully bring down right under the other one. And we're going to think for a moment, what times 3 gives you 2? Well, there's nothing times 3 that's going to give you 2. That just doesn't work at all. So what are we going to do here? We're going to, but we need a number. So we're going to just say nothing. Nothing times 3 is going to give you a 2. And that's going to give 0 times 3 is 0. Okay. And we're going to subtract what is left over. 2 minus 0 is 2. And all it did was just kind of, we have some stuff in the middle here. And then now we can finish it by bringing the 7 all the way down. And we think, what number times 3 is going to give us 27? And hopefully you think right away that, oh, well, 27 divided by 3 is 9, or 9 times 3 is 27. So I'm going to go ahead and put that 9 up there, completing that to $2.09. Am I done, students? No. Now I have to do something with that 9. 9 times 3 is 27. I'm going to write that down here. You see that okay? And then subtract, and that is going to give us 0. And when we have nothing left, no remainder, we are finished. So number 23, $6.27 times 3 divided by 3, excuse me, is $2.09. Okay, now we can check our work if we want to. It didn't ask us to. $2.09 times 3 should give us $6.27 if we did everything correctly. So let's see. 9 times 3, we have 27. And we carry the 2, write down the 7. 0 times 3, or 3 times 0 is 0, plus 2. There's the 2. And then 3 times 2 is 6. And there you go. We've proven that we did this correctly because we have $6.27 here at the end. Okay, so that was number 23, right? Pause the video if you need to, and let's go on to number 27, okay? Thank you. And of course, everything that's up there, you should have in your own homework, on your own homework page. So number 27, we have a problem that looks like 400, divided by 2 cubed, 2 to the 3rd power. So What goes first? Let's see. Remember our little song? Parentheses. I get to go first. And then we have powers, which we do this strength symbol. Powers and roots. There's no roots to do here. We multiply and divide left to right, and then we add and subtract left to right. So it's I get to go first. Powers, roots, multiplication, multiply and divide, add and subtract. And that is the order of operations that changes the rule where we're not going to just do something left to right. We are going to do it in the order that the rest of the world is going to do it in, which means we can't divide first. We have to do this power first. Okay? So 2 to the third power. That does not mean 2 times 3. That means, let me write it over here for you. That means you're going to take this base number 2 and you're going to say 2 times 2 times 2. So you're going to multiply that factor 2 by its times itself 3 times. So 2 to the third power means 2 times 2 times 2. It's like this 2 is exploding into this much bigger number. So 2 times 2 is 4, times another 2 is 8. So all of this 2 to the third power, remember, is 8, right? And what do we have here? We have 400 divided by 8. Now, maybe some of you are thinking, okay, that's not so hard. It's the same as 40 divided by 8, and add a 0 to that answer. What would that be? 40 divided by 8, add a 0, wouldn't that be a 5? 40 divided by 8 is 5. Add a 0 to make 50. But if you can't do that in your head, no problem, kids. You can always do it off to the side here. 400 divided by 8 and get the same answer. How many times does 8 go into 40? Right, not 4, because that would be a 0. That would be nothing up here. 8 goes into 40 5 times. So we're going to put that 5 up above the 0, the end of the number 40. 5 times 8 is 40. And that leaves us with 0, but we're not finished. There's still a 0 that we can bring down. Bring down that 0. And now ask yourself, 0 divided by 8 is what? Or what times 8 gives you 0? There's nothing times 8 that is going to give you 0. So the answer is 0 up here, or that piece is 0. 0 times 8 is, so some more zeros. 0 minus 0 is just 0, right? Sorry, it looks like little rocks or people now. And you have the answer is 50. Okay, see how we did that? So 400 divided by 2 cubed, or we could read it as 400 divided by 2 to the third power. The answer is 50. Now, I do want you to highlight your answer. I do not have a yellow whiteboard marker to show you how, but could you please have all of this written, and including the 400 divided by 8, giving us 50, and then highlight that 50 in yellow or pink or some bright color that doesn't cover it up, okay? So that when Mrs. Wright, Braden's mom, she'll be our aide while you guys are at home, and so she will be helping a lot. So if you see her, say thank you so much for all the copies she's making and all the help that she's giving Mrs. Conklin and I. And she will also help grade these. So Braden, your mom's watching, right? And we'll expect you to do a super good job, but you already do anyway. You're an awesome kid, right? Like the rest of my students. So I'm just teasing you. I love you guys. So number 27 is that, and then we move on to number 30. But yeah, we are very grateful. Mrs. Bryant, in case you're wondering, is just fine. She has just been asked to help the junior high teachers more during this time where everybody's teaching from home and from the classroom, and you guys are learning from home. But she's fine. She's just helping others because she was asked to, and Mrs. Wright is helping us, so we really appreciate her. Here we go. Number 30 says the table below is based on a survey about favorite flowers. Use the data in the table to make a double bar graph. Write one conclusion based on the graph. So let's see. We have, if you look at your book, we have a list of 3 flowers: roses, daisies, and mums. We have, I really like yellow mums. They're so pretty. And then we have the number of adults that like them and the number of children that like them. So the question is, it was a survey again about favorite flowers, and we are to make a double bar graph and write one conclusion based on the graph. So let's see, a double bar graph. So whenever we make a graph, we typically start off with 2 lines, one on the vertical and one horizontal. And then we write the, let's see, we write whatever is the information we have. Maybe we'll try it this way: mums, daisies, and roses. We could try it this way, or we could try it the other way and see which one works. All right, so now here we could do a graph for adults. Probably should have done it the other way. And we can do one for children. I'm just going to call them kids for short. Okay, and let's see. Adults. So we know that 6 adults like roses. So let's see. I feel like we should have done it the other way. Do you mind if I go ahead and erase it? Let me try it the other way. I would say it might make more sense to do roses at the bottom, so the different flowers, roses and daisies and mums. I thought I would try it the other way, but typically on graphs it makes more sense to have the numbers on the vertical scale. It's just more the way we see them, so probably would have been better to start off that way. Now we see the numbers. There's no 0 or 1 on the adults or children that like specific flowers, so we could maybe count by 2s. We know that they the highest number is a 9, so maybe we could count by 2s and go up to like 10 to cover all the range of numbers from 2 to 9 that we see there. And I think I will do just that. So let's start with, of course, this here, this little vertex, or what we call the origin, right, on a graph, it stands for 0, right? So let's go with, this will be like 2, about equal distance apart, 4, 6, 8, 10, which will cover the whole range. And then we will make a double bar graph. So for rows, we'll have 2 bars, one that is for adults and one for children, and same for daisy and mum. Okay, so I'm going to actually switch colors now, and I'm going to use, let's see, my favorite color lately has become red. I've changed my favorite color from like pink and turquoise to red lately. So I'm going to use red for an adult, and then I'm going to use green for the kids. Okay, Destiny's favorite color is green, so she's a kid. You guys are kids, so we'll go red and green. All right, so yes, there's a method to my madness, which means there's a reason why I do things, even if they are silly sometimes. Okay, so roses. How many adults like roses? We know that 6 adults like roses. So we are going to draw a bar that represents 6 adults liking roses. Okay, and then down here, we're going to maybe make a key, red and green. Can you see that? And we're going to say the red stands for adults, and the green stands for kids. Okay, can you see that okay? Is there a little bit of a problem with the lighting? Hopefully you're able to see everything okay. So how many kids like roses? 2. 2 kids like roses. So above roses, we're just going to draw 2 kids. I could just hear Rose saying, "Aw, we love you, Rose." And we do love roses. Roses are beautiful. Daisies. How many adults like daisies? 4 adults like daisies. So you're going to make another bar for daisies up until the number 4. Did I get that about right? Yep. And then how many children like daisies? 9 children like daisies. So I'm going to come across and say, that looks like about 9, somewhere between the 8 and the 10. And that is, so 9 kids like daisies. Okay. And then lastly, we have mums. How many adults like mums? You would say 5. So I'm going to go think right between the 4 and the 6. You could get a ruler if you wanted to. Try to get it as even as you can, so that this red one looks like goes up to 5. And then the next one, how many children like mums? It says 4. So that's about right here. 4 kids like mums, while 5 adults like mums. And there is what we call a double bar graph. So for all the information, there's 2 bars. 2 bars for roses, 2 bars for daisies, 2 bars for mums. So tell me something, one conclusion that you can see easily from this bar graph. Maybe your conclusion would be that adults like roses more than children do. Another conclusion, and I want you to write your conclusion, maybe you would say that kids or children like daisies more than adults do. Or that adults and children favor mums almost the same amount. Okay, so you are to write some conclusion. My conclusion in this case will be that adults prefer, Prefer, roses more, or maybe I should say adults like roses or prefer roses more than children do. I don't want to leave it with that they like roses more than children. The point is that they like roses more than children like roses more than children do. All right, so that completes our lesson for today. And I think that was hopefully really helpful to you. And you can jump on the rest of the non-star problems. Hopefully it doesn't take you more than about a half an hour or so to jump on there and do the rest yourself. Thanks for watching, and tomorrow check RenWeb for your next link and get everything ready for Investigation 8. Love y'all. Bye.